All of you, welcome back once again. In the last video, we have understood the architecture for the referral system we have in the smart contract, how we are fetching the data and feeding in our front-end component, and what are the data structure we have follow in the smart contract, which can deal with the other part of the business logic. So if you haven't watched that video, make sure to watch that. In this video, we'll try to understand that how we are providing the feature where user can buy the stable coin. This one is totally up to you whether you want to provide this particular feature in the contract or not. So as you can see, this is the front end structure we have right up here, where user can select any one of the token like USDT and USDC, and they can simply give their ETH and they can buy the quantity which they want to purchase. Here we have the rate of exchange which is going on, so you can simply update that to any number. So this is the price we have set at the moment. So currently the price of our stable coin is 0.001, but you can set this to any number. You can update this function. Per token price we have included, but you can simply update that. And we have that feature in the smart contract where you can update the price of the stable coin. So when you will update the price, for example, I want to update the price of USDT from this to, let's say, like 0.01, this much. So when you will update the price, it will be applied for both USDT slash USDC. It will apply for both because stable coins are stable coin, like both follow the dollar architecture. So we have to maintain that. So we're not going to set the price individually, one for USDT or one for USDC. This is going to be the fixed price which is going to be applied for both the one. That's the one thing you have to keep in mind, that we are following the stable price system which can apply for both the token. From here, user can select and they can able to fetch the balance of the ETH. That this will display the balance, that how much ETH they have in their wallet, because the buying will happen in. So for example, if I want to buy, let's say, give my 1 ETH and I will get this much, because the price ratio which we are following. So if you simply do the multiplication of 001 to, let's say, 1000, it will come to 1 ETH. That's the calculation we are following. This one is for single price and this one is the total. So you're going to multiply with that, you will get this one. Got it? So that's what we are following. So it's same for the USDT. User can give the quantity and they can simply click on this buy. It's going to make a call and they can simply purchase. So they can simply purchase and do the transaction. And when they will do the transaction, we are processing the data and we are displaying right up here, and it's coming from the local storage. So it's not always necessary that you have to keep the data in the contract. Sometimes you have to keep the data in the browser for the user so they can simply perform the transaction. It's not necessary that you have to keep all the history in the contract. In that way, your contract is going to be huge and you have to pay more gas consumption for deploying the contract. This one is not that important data. It has no use case in the business logic. That's why we are keeping this data in the local storage, and this data is going to be only visible for the client who is using the application in the front end side. So this is the simplest architecture we have. What function we have included? Only one function which allows us to do this transaction. So we have to keep the track of the token. So whether it's a USDT or USDC, we have to keep the track because every single token will have a unique ID, and based on that we are doing the tracking. And we have to also check for the balance, that how much token is available in the contract, because if there is no token available, there is no supply of USDT, USDC, then how would user will purchase? So we have to constantly provide the information to the admin that there is much supply you will have, and based on that we have to prevent and execute the transaction. We have the check supply, which we're going to calculate it and display the data that how much is going to be there. And fourth one is we have is the pricing. So this is the few things we are keeping, where we are providing the supply of the token and performing the transaction. So if I show you the smart contract, you can able to find that we have this function which allow us to execute it. So let me come back here and let me take you back to the code editor, and you will find that here we are keeping the price. So currently the price is set to be, let's say, we have is this one, stable coin 0.001, but you can simply update this price because we have that particular feature which allows us to update the price for the stable coin. And here you will find that we have this particular one. We have buy USDT and buy USDC. So user can simply call the buy USDT if they want to buy it, and they can call this one. It will follow the similar architecture, but we want to keep it two different sector. And we are also checking that whether the account is blocked or not, because we have the feature in the contract where we can restrict a particular account or any account to perform the transaction in our contract. So we are blocking that one. So this is the function which allow the buy. And if you find that we have a feature where we can update the price of the stable coin, so this is the function we're going to call it, and this can only call by the admin. So you have to build this kind of modifier. It's absolutely must to do the clear cut check that whether this particular account which is calling the function in the contract is an admin or not. And that way we can able to bring a secure system and prevent any kind of overlap, or re-entrancy attack. So you have to always make it this kind of modifier to do the check, and after that execute the transaction. So this is the system we have. I hope you have understood that how we are designing this particular architecture for providing the stable coin feature, but it's totally up to you. If you want to provide it, you can provide, or if you want to skip that part, you can do that. So you can see this is the event we have, and here you will find that we have the data structure which we have follow for the stable coin. So let me get it for you. So here we have the entire data. This is the event which we are keeping it and calling when the transaction is taking place to store the data. So we can simply build that. This stablecoin is the additional feature we have included. Some of the client want us to include this because they want to sell stablecoin at some extra profit. So that's why they like to include this particular feature in the contract. So now I hope you have understood that what model we are following, what kind of price ratio we are following. So if you set a stablecoin price, this can be applied for both USDT and USDT. That's the first thing. We have a function which allows us to update the price of the stablecoin. We have the function to buy the USDT and USDC, and we have the function which can track the entire history of the transaction, which we are doing on the front end side. So this is the few things which you have to keep in mind. I hope you have got it. With that, let's move to the next video.